Yeah, so like we discussed, this is the utmost of quality of product. I am looking to sell this. I'd give it to you for $75. Yeah, so it is in tip-top shape. It's still sealed. It's not been opened. Um, you know, I could see this going on an auction for anywhere up to $200, $300, and I'm willing to give it to you for 75. So as you can see, we've got two ply, and it is, it might leave a little rash or two, but I mean, overall, it's pretty solid stuff. Oh, wrong channel. Okay. Get it? So math. Hey guys, that's not embarrassing. All right. So today, what we're going to talk about is proportional relationships. I believe 100% this is the most important topic of seventh grade math. Um, so I'm going to show it to you in three ways, uh, or at least talk to you about it in three ways, and then focus on a word problem. So with proportional relationships, they can be represented in three ways. They can be represented by an equation, y equals kx, where k is your constant of proportionality. What's the constant of proportionality? That's what you multiply by each time. That is the constant rate that your proportional relationship is increasing by each time. Okay? Also known as the slope, right? For those of you that have done linear relationships, the constant proportionality is the slope for a proportional relationship. Also, for those of you that have done linear relationships, you'll notice if you take this and compare it to y equals mx plus b, that there is a missing b here. That doesn't mean that there's nothing here. It's plus 0. So what that tells us, if you remember, b is the y-intercept. So that means that a linear um, proportional relationship. So if you drew the line according to linear relationships, then it would have to pass through 0, 0. We know this is a line because it has a slope, and our x is not raised to a power. Okay, so that tells us then that if we were to graph it, it would have to be a straight line that goes through 0, 0. So when we are looking at the qualifications of proportional relationship, it must be 1, a straight line, and 2, pass through the origin, or 0, 0. Okay, what I've written up here is the lack of a y-intercept lets us know that the line passes through 0, 0. Okay, so again, the equation, y equals kx. The line, if you always see a graph, it'll always go through 0, 0 and be a straight line. And then if you have a table, you will probably notice a pattern. Our x's are going up by 1s, our y's are going up by 5s. So if we had to write that as an equation, that would be y equals 5x. Okay, that is the equation. All right, notice if I had plus 1 out here, that's automatically not proportional. And if you know anything about linear relationships, why is it not proportional? Because plus 1 means that our y-intercept is 1. Remember our qualifications. Straight line passes through the origin. This would not pass through the origin, but it doesn't have a plus 1. I was just showing you a counter example. And another way to check to see if this is proportional, you can follow the same steps. Is it going through 0, 0? You won't always see 0, 0 here. I just showed you that. You could have a table without the 0, 0, and you could work backwards to see if it does, or you should be able to pick any two pairs here and cross multiply them and get the same thing. But you should be able to test all of them, okay? So I just picked a random one. I said 1 and 5 and 3 and 15. So I put the x over the y. So I've got 1 over 5 is equal to 3 over 15. And when you cross multiply that, 1 times 15 is equal to 15. 5 times 3 is equal to 15. 15 equals 15. So if something is proportional, then the cross products will always be equal. Okay, that's very important. That's the best way to test a table. All right, so let's see a couple counter examples. If we have a graph, this is a straight line but does not pass through 0, 0, not proportional. This is goes through 0, 0, but it's curved, not proportional. And then this is a good counterexample. I shouldn't have included 0 and 1, but we're going 0, 1, 2, 3, 1, 2, 3, 4. There's clearly a pattern here. When you go up 1 on the x, you're going up 1 on the y. There should be a constant proportionality. There should be actually no. In this case, there's a slope, but there's no constant proportionality because it does not go through 0, 0. That's a dead giveaway. But also, if we cross multiply, I picked 1 and 2 and 2 and 3. So the x is 1, y is 2, and the x is 2 and the y is 3. And I put them over each other, cross multiplied. 1 times 3 is equal to 3. 2 times 2 is equal to 4. Right there, they do not equal each other. Therefore, this is not proportional. Quick and easy check, okay? And now I want to look at a word problem. And this is where you're going to see a majority of your work looking like this week, okay? I'm just fixing some of my smudges. So, you know what? I'll read the problem to you. Well, I'll show you. I just don't want you to see everything. So, Jonathan can paint 1/3 of a wall in 1 1/5 hour. How long will it take Jonathan to paint 4 3/4 of a wall at this rate? So the fact that we say at this rate, we know it's proportional. We've got a constant proportionality. Something's happening proportional. So the way to find this is to set up cross products. Okay? So what you want to do is you want to take what you know. What is the rate that you know? And we know from the problem that you can paint 1/3 of a wall in 1 1/5 hour. So we put 1/3 wall over 1 1/5 hour. That is your first thing. That's your scale. That's what you know. That's your measuring stick. So you can find any other proportion, any other value, as long as you know one of the other missing things given this proportion. Okay? And so that's going to be this rate. So that's going to be equal to, and we're going to put, what do we want to know? We want to know how long. How long? So that's going to be X hours. But then you could ask your question, do I put the X up top or the bottom? Your units have to match. There's a reason, not just to look neat, that I wrote wall and hour here. It's so I know what they represent. So if wall is on the top in my numerator, wall has to also be in my numerator of my other ratio here. If it's not, then the problem is going to be wrong. Your units have to match. It's very important. So 1 1/5 hour, we were looking for hours. Our hours were in the denominator of our scale. So our hours need to be in the denominator here. So then you just cross multiply. So you've got 1/3 times x, which is, I should rewrite it actually, which is 1/3 x. Okay? And that's equal to whatever 1 1/5 times 4 3/4 is equal to. And I'm just going to take you back here a few years and do a little review here. So we've got 1 1/5 times 3 3/4. The first thing you want to do is turn them to improper fractions, and that would give you 6/5. Okay, 6/5 times, and what's that? 4 times 3 is 12, plus 3 is 15. 15/4. So 6/5 times, is that right way? Yeah. 6/5 times 15/4. And I did the work here, but I'm going to show you again. You can cross simplify, just look across. So when I look at 6 and 4, 2 goes into both of those. So this can become a 3, and this can become a 2. And when I look here, 5 and 15, 5 goes into both. So this can be a 1, this can be a 3. So when you multiply straight across, you get, oh, I did my math wrong originally. That's why, yeah, that's why you're here, to watch me fix it. This is the part where I would edit this out. So we're going to go ahead and edit this out, okay? So go ahead and start editing, and obviously, here's my editing tool. So we're going to do this problem live. Oopsies. So we've got 1/3 x is equal to, and when we did the math here, 3 times 3 is 9, and 1 times 2 is 2. Okay, so again, that should have been 6/5 times 15/4. 1 times, and we can simplify. 2 goes into both of those, so that's 2 and 3. 5 goes into both of these. That's 1 and 3. 3 times 3 is 9. 9 over 2. That's not embarrassing. It happens, guys. We all make mistakes, right? Everyone makes mistakes, and everyone has those days. So we know this is 1/3 x. I forgot my x here. Gosh, I'm making it all good, right? 1/3 x is equal to 9 over 2. So normally we say divide by what's touching your x. Divide by what's touching your x. But what's touching my x is a fraction. And how do you divide by a fraction? You multiply by the reciprocal. So we're going to multiply by 3 over 1 to both sides. That's going to cancel, leaving us with x is equal to 9 times 3 is 27 over 2. And 27 divided by 2 can be changed into a mixed number. You don't have to, but it's good to see it this way, especially when we're talking about hours. And that's going to be 13 1/2 hours. So that is how you do a proportional relationship problem. Okay. Obviously, I made a mistake here. It happens. So if you have questions, please leave a comment. If you like this video, hit it with a thumbs up. That's what they say on YouTube. You know, I'm trying to be cool. Subscribe, share it, whatever. But in all seriousness, if you have questions, please let us know. That was a silly mistake, but it's all good. It happens. So let's go ahead and hit the outro. Math. All right, switch channels. Okay, so back to selling this stuff. I was thinking that a solid 75 is just pretty fair. I mean, everybody in the world needs this right